Hello, Ellen. Farhat, Saifullah. Am I audible to everyone?
Yes, sir.
Yes, sir.
How was your test? How was your test?
Good, sir.
And how much did you get in that?
I didn't get my results, sir.
Okay. Let all of them come, then we will start. Today I'll complete this chapter. Do you have any doubt in any of the section like electric potential?
No,
Farhat,
sir.
just a minute. Just a minute. Okay, let's start. Electric potential energy. What do you mean by electric potential energy?
There's a work done in moving the charges from one place to another.
The amount of work done. Just a minute. Okay, let it be P1 and P2. Let it be Q1 charge. If the amount of work done bringing a charge from infinity to the given point, fine. So the amount of work done bringing a charge from infinity to the given point is known as electric potential energy. Fine. So let it be Q1 if we have to bring the work done bringing a charge Q1 from infinity to the point P. Likewise, let it be Q2 charge from infinity to P2. So the amount of work done bringing a charge from the infinity to the given point, that amount of work done is known as electric potential energy. Further, it is defined as, so work done potential equals to work done over Q. That is, work done is always equals to potential. And it just remember one thing, whenever we have to calculate the work done, it means we have to calculate the potential energy. Fine. It is defined as only in conservative field. So electric force is a conservative force, and the field which is generated by a charge is known as conservative field. Like gravitational field is also a conservative field. Fine. Like potential energy of two system of charges. Let it be two charges. Let it be 2 points, P1 and P2. Fine. So the potential energy of system of charges. First of all, we will discuss the system of 2-point charges. Let it be 1 point Q1 is the charge we have to bring to point P from infinity. The amount of work done in bringing a charge Q1. Likewise, in bringing a charge Q2 from infinity, if we sum up the total work done, you'll get this potential energy. So the potential energy of two system of charges equals to 1/4 epsilon Q1 Q2 over R. So if I draw so let it be, these are 2-point charges, Q1 and Q2, separated by a distance R. So the system of two charges, the potential energy of two system, the potential energy for a system of 2-point charges equals to 1/4 epsilon Q1 Q2 over R. Likewise, potential energy of more than two charges. So this is equals to K over 2 summation n I comma j, I not equals to j, Q1 Qi Qj over I Rj. Here K equals to 1/4 epsilon. For example, if we have to calculate the potential energy of three charges, so let it be three charges. This is Q1, this is Q2, this is Q3. R1, R2, and R3. If we have to calculate the potential energy of the system of three charges, then this is equals to 1/4 epsilon. First of all, we have to calculate the potential energy of Q1, Q3, that is Q1, Q3 over R1 plus 1/4 epsilon Q1, Q2 over R2 plus 1/4 epsilon Q2, Q3 over R3. Fine. Whenever we have to calculate the system of a system, whenever we have to calculate potential energy of a system, it means we have to calculate the all possible pairs. Means if we have to calculate the potential energy of three charges, then we have to calculate the potential energy of two charges Q1, Q3, then Q1, Q2, and Q2, Q3. Fine. And then some of them you get the total energy of the system. All right. Is it okay to everyone?
Yes.
Yes, sir.
Now try this question. You have 2 minutes to try this question. First, the charges plus q and minus q are placed at the points A and B respectively, which are at a distance 2L from 2L apart. C is the midpoint between A and B. The work done in moving a charge plus q along the semicircle CRD. Fine. So we have to calculate the work done. You have 2 minutes. Try this question. Then we will go further. Fast. Let me hint you. First of all, you have to calculate. Okay, try. Sorry. Look, I repeat. Look, what we have to calculate initially, we will calculate the initial potential energy. So initially the charge is located at C, which is the midpoint of A and B. So what did I tell you? We have to take all possible pairs. So we have, first of all, the potential energy between small q and capital Q, that is 1 over 4 epsilon q capital Q over L. Likewise, q and minus q, 1 over 4 epsilon minus q capital Q over L. And likewise between the charges plus q and minus q, that is this. If you calculate it, you will get this much of energy, minus 1 over 4 epsilon q square over 2L. Then the charge is located at D. Then again we have to calculate the all possible pairs. For what is the distance D? What is the distance D, by the way?
Real.
Sorry, L. What is BD?
L.
L. Okay, this is L. Now again, U2 final energy. Again 1 over 4 epsilon minus q square over 2L plus 1 over 4 epsilon capital Q small q over 3L minus 1 o plus 1 over 4 epsilon minus q capital Q over L. Okay, if you sum up that, you will get how much, Alan? Did anyone calculate it? If you calculate, what would you get?
So I got minus 2k.
1 over 4 epsilon. This is L. This is minus q square plus q over 3 plus minus q over L. Okay. Now substitute. Please solve for me. Sorry, just a minute. This is okay. How much? It would be q. If you solve it, you will get minus q square. What is the answer, by the way? If you calculate it, you will get minus q square plus capital Q minus 3q over 3, 1 over 4 epsilon L. If you solve it, you will get minus q square minus 2q over 3. Now we have to calculate the work done. Work done means work done equals to U2 minus U1. Now solve it. What is UT? 1 over 4 epsilon L bracket, it is minus q square minus 2q over 3 and minus plus q square over, sorry, over 2. Okay. So 1 over 4 epsilon L, if you solve it, did anyone calculate it? What is the answer, by the way?
So that's option D.
Option D. You got the same thing, Alan. U2. In U2, you got the same thing.
So I got a different answer though.
Sorry. Oh, just a minute. I made a mistake. This is 2. This is 2. This is 2. So these 2 will cancel out. So minus 2q by 3. That is equals to 2 will cancel out. So minus qq over 6 pi epsilon L. This is the answer. I think this is D, isn't it?
Yes, sir.
Okay, fine. So if you get, whenever you get this kind of stuff, means whenever we have to, there is a system is, if a system is given in any of the question, if we have to calculate the work done, what we have to do it? First of all, we have to calculate the initial potential energy, then final potential energy of the system, then subtract initial potential energy from the final potential energy to get the required work done. Is it okay till here? Farhat, Saifullah, Alan.
Yes, sir.
D is the answer. C. Saifullah, did you get it? You made a mistake.
Yes, sir. I got it.
Aksha, Hiba, Mahmuna. Whenever we have to calculate the work done, it means, first of all, we will calculate the initial potential energy of the system, then final potential energy of the system. Then we have to subtract the initial potential energy of the system from the final potential energy of the system to get the required work done. That's it. Now further, potential energy in external electric field. So let it be an external electric field here. Let it be a source charge. Let it be a source charge. This is a source charge. So everyone knows this thing, that charge creates a source charge creates an electric field around it. And if we bring a charge from infinity to the given point, so the amount of work done in bringing a charge from infinity in external electric field, that is stored as a potential energy of the single charge. So E equals to Q times VR. VR basically, so let it be, this is the point, R is the distance from the source charge, and if we bring any charge from infinity to the given point, that is P, so the amount of work done bringing a charge from infinity to the given point, VR is the potential. VR is the potential. First of all, we will calculate the potential due to this source charge at the given point. Then we will multiply the given charge that we have to bring to the given point. That is the potential energy of the single charge. Likewise, potential energy of a system is given by, means let it be 2 charges. If we have to bring from infinity in presence of external electric field, this is the work done. So Q1 into VR1. R1 is the distance where we have to locate the Q1 charge. R1 V means, let it be, this is a source charge, let it be 2 points, P1 and P2. R1 is the distance, R2 is the distance from P2, that this is a source charge due to which electric field is created. Now if we have to bring Q1, so first of all, what we have to calculate, we have to calculate the potential at point P1, and we have to multiply with the charge that we have to bring to the given point. Likewise with the Q2, and we have to, this is R12 is the basically the distance between the 2 charges. So this is the potential energy of a system of 2 charges in presence of external electric field. Is it okay to everyone? You have to remember this formula. Is it okay, Farhat, Mohammed, Saifullah, Alan? Sorry.
Yes, sir.
Okay. Now further. Now potential energy of a dipole in uniform electric field. This is the potential. This is the formula. If you put if you put an electric dipole in external electric field, then what is the potential energy? Work done equals to UPE. That is, sorry, just a minute. PE cos theta 1 minus cos theta 2. And if a dipole rotated by an angle, theta 1 is 90 degree to theta 2, this is the potential energy. You have to remember this formula. A stable equilibrium means when theta is 0, means the dipole movement is parallel to the electric field. So the potential energy in that case will come out minus P. In case of unstable equilibrium, theta is 180, P is anti-parallel, so E equals to PE. Potential energy is maximum. Now this question, in bringing an electron towards fast, 30 seconds to do this question fast. B increases. Saifullah, pass. Farhat, Mahmuna, Aksha, write your answer in chat box fast. B. Farhat, B. Alan, B. Mahmuna, what's your answer? Answer is B. The potential energy will increase. Because what did I tell you? What do you mean by potential energy? The amount of work done. So definitely there is an electron. If we have to bring an electron nearby it, then we have to do some work. So that work is stored as a potential energy of the system. Just a minute. B is the correct answer. Fine. So bringing an electron towards another electron, it means we have to do some work against the repulsive force. So that work then is stored as the potential energy of the system. So increase. So next, this question you have to try at home. This one. Fine. So identical charge minus Q placed at each corners of a cube of a side. Then the electrostatic potential energy of the charge placed at the center of the cube. This question you have to try at home. Shall I move further? Next topic. Is it clear to everyone electric potential energy? Now, electrostatic equilibrium means if you place a conductor in external electric field, if you place, this is the conductor, if you place a conductor in external electric field, so the free electrons of the conductor, when they experience a force and they will try to move in the opposite direction of external electric field. So this is a positive plate, this is a negative plate, and there is a distance between the two plates. So as we know that E equals to V over D. So electric field will be created, that is external electric field E naught. And if you place a conductor in external electric field, so the free electrons of the conductor, they will start moving in the opposite direction of external electric field. And this movement, the movement of the electrons continues till the induced electric field. Induced electric field means the electric field which is induced which is created within the conductor. So the movement of the electron continues till the external electric field equals to induced electric field. So, and the net electric field inside the conductor becomes 0. This is known as electrostatic equilibrium. Is it okay? So what do you mean by electrostatic equilibrium? When the net electrostatic field inside a conductor becomes 0, that is electrostatic equilibrium. Now properties. Everyone is familiar with these properties. First, under static conditions, electric field inside a conductor is 0. Electric field is normal to the surface of the conductor. And the whole body of the conductor is equipotential surface. Because E inside is 0, it means, and in the last class I told you dy over dr equals to 0. So V will come out equals to constant. So the potential is constant. That's why the whole body of the conductor is equipotential surface. What is equipotential surface? What is Saifullah, what is equipotential surface?
When potential is equal everywhere.
So so the whole body of the conductor is equipotential surface because electric field inside is 0 and E equals to dy over dr equals to 0. So the differentiation is 0. It means the potential is constant. When do we say the differentiation 0? When the quantity is constant. Now electrostatic shielding, you have to remember just remember the definitions. Means the phenomena of making a region free from the electric field. That is a car. Car is an example of electrostatic shielding. Electrostatic pressure. So let it be a conductor having charge plus Q resides on its surface. So the force per unit area on the surface of the conductor due to its own charge means the pressure means the force exerted per unit area by its own charge, that is known as electrostatic pressure. That is that is equals to sigma square over 2 epsilon. Sigma surface charge density. What is sigma? Surface charge density. That is charge per unit area. This is sigma. So this is the formula to calculate the electrostatic pressure, that is sigma square over 2 epsilon. This is also equals to 1 over epsilon E square. E is the field. Further, now earthing, a conductor. So earthing basically good conductor of electricity. And just remember, if you earth any of the conductor, then its potential becomes 0. Just remember this thing. A earth conductor, the potential of earth conductor is always taken to be 0. Fine. This is a conductor. The positive charge resides on its surface. Let it be. This is a concept of conduction. So let it be 2 spherical shells plus Q is plus Q is the charge on the inner shell due to the induction, negative charge induced within its inner surface and positive charge on this. And if you earth this, then the outer surface, the charge on outer surface will be neutralized. Like by this, these are 2 shells. And the positive charge accumulated on the outer shell. And if you earth the inner shell, then definitely electrons from the ground will come and to accumulate on the surface of inner shell. And just remember one thing, the potential, if you earth any of the conductor, then its potential becomes 0. So just remember this. Now, if we have to calculate, so let it be Q1 is the charge that is accumulated on the outer shell. And if you are the inner shell, and if we have to calculate the net charge, so the potential, we have to use the concept. So net potential of the inner shell is 0 because the inner shell is earth. So what is the total potential? In the last class, I told you how to calculate the potential. So due to its own charge, let it be Q2. Q2 is the charge that is accumulated on the inner shell. 1 over 4 epsilon Q2 over R2. Q2 is the charge that we assuming accumulated on the inner shell plus Q1 plus R1 equals to 0. And Q2 will come out minus Q1 over R1 times R2. Fine, just remember this formula and try this question fast. Now we have to calculate the charge on the inner shell fast. And write your answer in the chat box fast. Heba, Alan, Farahat, Mahmuna, write your answer in chat box fast. Fast. Write your answer. Minus 3q. Alan, why did you write kq over r square? This is not the answer, all right. Mamuna, write your answer. Farhat, write your answer fast. Look how to do. So potential equals to 0. Now potential equals to 0. So 1 over 4 epsilon. Let it be q dash is the charge. Okay. So 1 over q dash over r and plus q over 3r equals to 0. So q dash plus q over 3 q dash equals to minus q over 3. I think this is the answer. This is the answer. Minus 3q, but why? Due to the outer shell, the potential will be same everywhere. And what is the potential due to the outer shell on its surface? That is q over 3r. So minus q over 3 is the answer. Okay. So what did I do? I just calculated the total potential of the inner shell and equate equals to 0. As I told you, if any conductor is earth, then we have to assume the potential is 0. Okay. Is it clear to everyone? This question?
Yes, sir.
Okay.
Yes, sir.
Now dielectrics. What are dielectric? Basically, dielectrics are insulators. Fine. And if you place dielectric and external electric field, then a dipole moment is created. Fine. So it induces a dipole moment within the dielectric. So let it, this is a dielectric. This is positive. These are two plates having surface charge density plus sigma and minus sigma. And if you place a dielectric in external electric field, then an electric field will be induced. Fine, within the dielectric. And just remember, the net field inside the dielectric is not equals to 0 because it is not a conductor, it is an insulator. Fine, types of polar dielectrics. Fine, in with the center and the of negative charges and positive charges are separated. Fine, like HCl and H2O. If you place polar dielectrics, just remember one thing, the polar dielectrics have some permanent dipole moment, and if you place an external electric field, then the direction of dipole moment and the external and the electric field will be same. Likewise, non-polar dielectrics in which the center of negative and positive charges coincide, but in case of polar, they don't coincide. No dipole, no permanent dipole moment, example O2 and S2. Polars and non-polars. Polarization is defined as dipole moment per unit dielectric. So dipole moment of dielectric over per unit volume. Dielectric. It is also equal to surface charge density with surface charge density Q over area. You have to remember the definitions. Electrical susceptibility. Polarization is directly proportional to the external electric. Polarization is directly proportional to the net electric field within the dielectrics. So if you remove this proportionality constant, you will get epsilon naught chi electric field. This is chi is known as electrical susceptibility. This is defined as polarization per unit permittivity per unit electric field. Net electric field induced within the dielectric. This is the relation. This is K is the dielectric constant and chi. This is the relation between K and chi. Okay. Now capacitor. Important topic, capacitor. What is a capacitor? Basic. Alan, Farhat, what is a capacitor? What is a capacitor? Farhat? Alan, what is Saifullah, Mahmuna? What is capacitor?
A device to store or hold charge in it.
So basically, a capacitor is a device used to store electric energy, sorry, potential energy or electric charge within it. This is a symbol of capacitor. Now, capacitors. If you give charge in any of the conductor, then it is found that potential also increases. Fine. So capacitance, so Q is exactly proportional to V, and if you remove this proportionality constant, so you have to use a constant that is C. This is known as the capacitance of a conductor. So what do you mean by capacitance? Capacitance means the amount of charge given to a conductor to increase its potential by unit amount. That is known as capacitance of a conductor. Fine. This is the formula. SI unit is farad. And how will you define 1 farad? So 1, if 1 coulomb of charge is given to the conductor to rise its potential by a unit amount, then the capacitance of a conductor is said to be 1 farad. Dimension formula is this: mn minus ml minus 2 t raised to r 4 a square. A is ampere. Just remember one thing: capacitance depends on the shape, size, and the separation of the system of the two conductors, but it is independent of the charge given to the body. Initial charge given to the body. Now, capacitance of isolated conductors. This is a spherical conductor having radius r, capital Q. Let it be. This is a charge accumulated on its surface. So, capacitance of a isolated conductor is 4 epsilon, 4 pi epsilon r, and completely depends on r. The capacitance of spherical capacitor. These are these two spherical capacitors having radius A and capital B. B is the radius of outer shell and A is the radius of inner shell, and the outer shell is Earth. Now the capacitance of this is C equals to 4 epsilon AB over V minus A. This is the formula. Now try this question fast. Fast. Try this question. Very easy question. We have to use the formula. And write your answer in chat box fast, everyone. Very easy question. Right formula, you have to use it. Oh. Well, micro. Okay, Q equals to CV. What is C? Microfarad. 16. What is 75? 3/4. Okay. 12 microcoulombs. Okay. Now, likewise, the capacitor of cylindrical capacitor. Fine. So L is the length, B is the outer radius, A is the inner radius. This is a hollow cylinder. Now, this is the formula we have to use this. 2 pi epsilon L is the length log B minus A. This formula. Very important topic. Now, combination of a capacitor. There's a 3 capacitors. Let it be 3 capacitors if they are connected in series. So the equivalent capacitance will be 1 over C1, 1 over C2, 1 over C3. Fine. So this is the formula to calculate the capacitance in series. And just remember, in series, charge is same and potential is V is different. Fine. Let it be n identical plates like this. N identical plates. So they contribute n minus 1 capacitors. Fine. If let it be n number of plates, how many capacitors will be formed by n number of plates? N minus 1. And if they are connected in series, if they are connected in series, then the equivalent capacitance epsilon A over n minus t. This is the capacitance, equivalent capacitance. Parallel grouping, let it be let it be 3 capacitors are connected in parallel. If we have to calculate the capacitance, then C equivalent equals to C1 plus C2 plus C3. And for n, C1 plus C2 please C3 dot Cn for n number of capacitors. Okay, n. So C equivalent equals to C1, C2 dot up to Cn. So let it be n plates, n identical plates are arranged such that even numbers of plates are connected together. These are even number of plates are connected together and odd number of plates are connected together. Then the equivalent capacitance will come out n minus 1 epsilon A over D. Just remember, let it be n identical capacitors. First they connected in series, then parallel. Then what is the ratio? So Cp over Cs equals to n square. This is the formula. Now try this question. In NEET, the questions you'll get based on formula. When 3 capacitors, each of capacitance C of breakdown voltage, it means the different voltage. Or we are joined in series, the capacitance and breakdown voltage of the combination will be fast. 2 to 3 minutes, hardly. Try and write your answer in chat box fast. Fast, write your answer in chat box. Write your answer in chat box fast. Write your answer in chat box. Alan, Saifullah, Farhat, Mahmuna. The 3 capacitors, each of capacitance and of breakdown voltage, we are joined in series. Voltage V. The capacitance, the breakdown voltage of the combination will be. Farhat, Mahmuna, am I audible to everyone?
Yes, sir.
Okay. Look, so let's do this question. If the 3 capacitors having potential, each having potential V, what is the total potential? Let it be 3 capacitors. Okay, now we have to calculate the equivalent. This. It will have V, it will have V, it will have V. What is the total potential? Alan? Saifullah, what is the total potential? Farhad, am I audible to you? Hiba, Aksha, am I audible to everyone?
Yes, sir.
Yes, that's
Okay.
3V.
3V. So the total potential equals to 3V. And what is the capacitance?
C by 3.
C over 3. Okay. Now first is the answer. Okay. Sorry.
Option C, yeah.
Okay, sorry. C. Okay. Let's move further. Now try this question first. A network of 4 capacitors of capacity equal to C. So C1 is given equals to C, C2 is given equals to 2C, C3 equals to given 3C and C4 equals to 4C. And we have to calculate the charges on Q2, the ratio Q2 and Q4. It means Q2 over Q4 ratio we have to calculate. Fast. See, Farad, correct. 2 okay, take your time, 3 minutes. Fast. What is B? Okay. Farad, Saifullah, Alan B. Okay. What about others? Write your answer. Maimuna, write your answer in chat box. Maimuna, write your answer in chat box.
Yes, sir, I'm ready.
Let's discuss this question. So C1, C2 and C3, all three are in series and C4 is in pair. C4. So this is C4, this is C1, C2 and C3. This is C4. That would be C3, C2 and C1. This is the setup. Fine. So C4 and all and rest of the three capacitors are in parallel. So the potential will be same. So if I calculate Q4, then it will come out 4C the capacity Q equals to CV V. Now, then we have to calculate the equivalent capacitance of all three capacitors. Now, what is this? C equivalent equals to C plus 2C plus 3C. If I calculate it, you will get 1 over 2, 1 over 3. So it would be 1 over, this is 6, this is 5, 6 plus 3 and 2. It would be, I think, 11, isn't it? The equivalent capacitance.
Yes, sir.
11 over 6C. So the C equivalent. So C equivalent come out 6C over 11. Okay. Now, since all three capacitors are in parallel and the charge will be same, so Q2 will be, V is the potential, it be, and what is C? C is 6C over 11. So 6CV over 11, this is Q2. Therefore, Q2 over Q4 equals to what is Q2? Q2 is 6CV over 11 and Q4 is 4CV. CV will cancel out. 6 over 11 into 4, 3 over 2, that is 3 over 22. This is the answer. What do we have to calculate? 3 over 22. Okay, B is the answer. Okay. Saifullah, you made a mistake.
Yes, sir.
B is the. Now further. Read student bridge. Let it be 5 capacitors C1, C2, C3, C4, and C5. Fine. This is the balance condition. This is balanced condition. Fine. So in balance condition, no charge stored in C5, so it can be removed. Okay. And you can do in this way. This is C1, this is C3, this is C4, and this is C2. Fine. So in balance after means if this is the condition, then you can draw this circuit in this way also. Now try this question fast. Fast. 2 minutes to do this question fast. Look, first of all, we have to draw. So if it is A, it would be A. Sir, X and Y. Sir, where is X and Y? So this is X, this is Y. Okay. If it is A, then it would be A. If it is B, it would be B. Fine. Now this is, it would be A, C, this is B, this is D. Now there is a capacitor between A and B. Fine. Likewise, between A and C also. C and D also, this. B and D is also. And C and B is also. Fine. So this is also C because all capacitors are identical. This is X, this is Y. Now, first of all, we have to check the balance condition. So 6 over 6 equals to 6 over 6. So this is a condition. So we can remove it. We can remove this capacitor. So final circuit will be like this. This is C, this is C, this is C, this is C. Now, if you solve it, you will get, this is, both are in series, then C over 2. This is also C over 2. This is X, this is Y. Fine. If you solve it, the answer will be C. Okay, that is 6 microfarad. Okay, very easy question. Is it clear to everyone?
Yes, sir.
So A is the answer. Next. Now parallel plate capacitor. Now parallel plate capacitor. That will be two plates. That will be two plates having surface charge density plus sigma and minus sigma. Fine. Now we have to calculate the capacitance of parallel plate capacitor. Sigma is the surface charge density, that's Q over A. And if we have to calculate the electric field between the two plates, that is equals to E equals to sigma over epsilon. Shall I calculate? Shall I show you how does it come? For everyone knows this thing, sigma over epsilon is the electric field between the parallel plate capacitor. Is it clear to everyone? This is the electric field. Now potential difference, what is potential difference? Electric field times D. Fine. So electric field is, potential is electric field times D. And what is electric field? Sigma over epsilon times D. Now capacitance is Q over V. What is V? Epsilon. V is sigma epsilon over D. So if I substitute here, look. So what is Q? Q is A. What is V? Sigma over epsilon times D. Just a minute, sorry. Fine. So if I Q is as it is, sigma over epsilon will come up. And D, what is sigma? Sigma is Q over A, D epsilon. Fine, Q will cancel out. So A epsilon times D. Fine, this is the answer. Okay. Now further. Just remember one thing, that capacitance of a parallel plate capacitor is proportional to the area and proportional to the distance between the plates. And it is also proportional to the permittivity. Now, force between the parallel plate capacitor. These are the two plates, the force acting them is. So force is Q times E. So Q is the charge in any of the plates. So Q times E is the electric field is. Electric field due to a plane sheet is sigma over 2 epsilon. Fine. If you multiply the charge with any of the plate, then you will get the force. That is Q times E. Q is sigma times Q. F is Q times sigma over 2 epsilon. Fine. This is the final formula to calculate the force between the plates. 1 over epsilon A E square. E is the electric field between the plates. Sigma is the surface charge density. Epsilon naught is the permittivity of the free space. This is the force if there is no dielectric between the plates. Further, the force is attractive because the charges are opposite. Just remember this thing. Instead of two plates, if there are n similar plates at equal distances from each other, find n equal distances, let it be D, 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 and alternate plates are together, means positive, negative, positive, negative. Then the capacitance is given by this. Now try this question, parallel plate capacitor. Here is the Fast. Write your answer in chat box. A parallel plate air capacitor has capacity C. Distance separation between the plates is D. The potential difference V between the plates. Force of attraction between the plates of the parallel plate capacitor is given by fast. Write your answer. By the way, what was the force? Epsilon epsilon A E square. This is the formula. Now, what it is not given? The electric field is not given. So we have to write electric field in terms of potential. Area is also not given. Fast. Just remember the concept that force is Q times E. And what is Q? Write your answer in chat box. Abdullah. Sorry, Saifullah, done. Mamuna, write your answer.
No, 1 minute, sir.
Mamuna, C. Write your answer fast. B. Alan, what happened to you? Farhat. Farhat, what's your answer? Farhat, what's your answer?
Sir, I'm done.
Okay, let's do it. Alan, what happened to you? Now, force is Q times E. Okay, and what is Q? Q equals to CV. Fine. And what is E? V over D. No, this is not the correct answer. C, the answer. C. Look, just a minute. Give me a minute. Let me check the answer. Okay. We will do it eventually. First of all. So I am also getting the same answer. That is CV square over D. So C is the answer, but I'll confirm before. Fine. So B is the answer. Now, capacitance of partially fixed, so let it be a dielectric is placed between the parallel plate capacitor having dielectric constant K, having thickness T. Fine. So the capacitance equals to epsilon A over D minus T plus T over K. Now if T equals to D, then the capacitance becomes K times C naught. C naught, basically the capacitance in free space. If K equals to infinity, then this is the required capacitance. If T equals to D, the capacitance becomes infinite. If more than one dielectrics are placed between the capacitors, like these are the two capacitors, like 1, 2, 3. So if more than one dielectric slabs are placed between the capacitors, the capacitance equals to epsilon A D minus T1 minus T2 dot Tn plus T1 over K1. K1 is the dielectric constant of first slab, then second slab K2, and so on. Now try this question first. Is question visible to everyone?
Yes, sir.
Okay. Is it visible to everyone? Done? Done? Write your answer in chat box. Done? Oh, just a minute. B, Jasola. Now the capacitor is parallel capacitor with air medium 6 and dielectric capacitance is 30. So what is the permittivity? Very easy question. So K equals to C medium over long. That is, what is C medium? C medium is 30 microfarad over 6 microfarad. So 5. And what is, so the permittivity of the medium. So what is permittivity? Permittivity of the medium over permittivity of the free space. So it will come out 5 times. Just a minute. Is it okay? You have to multiply with epsilon naught. Okay, this is the answer. Shall I move further? B. You have to multiply with epsilon naught, that's it, you'll get the answer. Shall I move? Now, energy is stored in a capacitor. So energy is stored in a capacitor. So what do you mean? Sorry, electrostatic energy. So put energy stored in a capacitor. So the amount of work done. So the amount of work done in charging a capacitor, that is known as energy stored in a capacitor. Its formula is 1 over half into CV square equals to half Q square over C or half QV. This is the formula you have to remember. These are the 3 formulas we have to use according to the given. Now energy density between the plates. Energy density is always defined energy stored per unit volume. So its formula is, so energy stored means density, that is equals to energy density equals to energy per unit volume. Try this question fast. Just a minute, everyone. This is the wrong answer. So remember one thing. So charge is correct. What is charge? Charge is Q times CV. And what is the electric field due to a plate is 2 over epsilon. This is the electric field. And what is sigma? Sigma is Q over 2 epsilon A. So what is the capacitance of a parallel capacitor? Epsilon A over D. We can write Q, this is C square V square, because Q equals to CV, we can replace. Fine. And what is epsilon A is, what is epsilon A? Equals to CD. 2 times CD. Now the C will cancel out. So CV square over 2D. I think this is the answer. B is the answer. Okay. Is it clear to everyone? Is it clear to everyone? So B is the answer. Okay. B is the B is the B is the answer. Okay. Now try this question. Alan, did you get it, the last one? Farha,
Yes, sir.
Saifullah, Mahmuna. Now try this question. A 4 microfarad is charged to 400 volt, then its plates are joined through the resistance of 1 kilo ohm. The heat produced. Heat produced means we have to calculate the energy first. The remaining. D. B. Write your answer fast. Fast. What is D? Which formula we have to use it? Which formula? Farhad, which formula we have to use it? Farhad, Mahmuna, which formula we have to use it fast? Farhad, Mahmuna, Alan, which formula we have to use it? CV square over 2. So E equals to half CV square. What is C? What is C? C is 4 microfarad. So 2 will cancel out. This is 1600 into 2. That is equals to 32. This is 32 minus 6. That is equals to 0. Just a minute. 4 zeros. It will come out. This is 16 into 2 into 10 raised to power minus 2, 0.32. So fine. Sorry for inconvenience. Now the common potential or the redistribution of charge. So let it be two conductors. Let it be two conductors having charge Q1 and Q2 and having potential V1 and V2. Now if we let it be these two conductors are connected by a conducting wire. So what happens? The charge flows from the conductor having higher potential to the conductor having lower potential. So after the connection, the common potential is Q1 dash. Let it be Q1 dash and Q2 dash are the final charges accumulated on the conductor respectively. So V equals to Q1 dash plus Q2 dash over C1 plus C2. So Q1 dash is C1 V1 plus C2 V2 over C1 plus C2. These are the final charges. Q1 dash equals Q1 over C1 plus C2, Q1 plus Q2. Q2 dash equals to C2 over C1 plus C2, Q1 plus Q2. These are the final charges. Now, if two capacitors are connected in such a way, their dissimilar plates are connected, means positive is connected to the dissimilar means positive is connected to the negative. Then the common potential will be C1 V1 minus C2 V2 over C1 plus C2. This is the formula. All right. This is okay to everyone. Is it okay to everyone?
Yes, sir.
Okay.
Yes, sir.
Now further, if the two conductors are connected by conducting wire, so definitely a wire will have some resistance. So there will be a loss of energy. So the loss of energy is equals to C1 plus C2 over 2 C1 C2 V1 minus V2. This is the formula. Remember this formula. Now try this question.
Sir,
Fast.
1 minute. Can you show me the formula again?
Okay.
Yes, sir.
Okay, fine. Now try this question. Very easy question. Just a minute. Now try this question. Two identical capacitors C1 and C2 of equal capacitance are connected. So initial energy in this question is half CV square. Fine. First is connected to the C1. So that is the capacitance, equal capacitance, let it be C. Fine. Now, finally, losses energy equals to half C1 C2 over C1 plus C2 bracket V1 minus V2 whole square. So what is C1? C1 is C, C2 is C. So it would be C square, C1, C2, both are same. So 2C. And what is V1? V1 initially is V1 is the potential connected to C1, that is V, and V2. There is no batteries connected to the C2, so potential will be 0. So equals to CC will cancel out 1 over 4 V square CV. Now percentage loss. Percentage loss means half CV square, sorry, 4 CV square over half CV square times 100, cancel out half, that is equals to 50% percentage loss. Okay. Everyone is getting the same answer, 50%. Is everyone getting the same answer, 50%?
1 minute, sir.
Okay. Farhat, Alan, Mamuna,
Yes, sir.
50%, are you getting the 50%?